So, in today's session, we'll first have a revisit to our discussion from the 11th live session that was concluded last week in a brief manner. Then we will go through the discussion of week 12 content in a much simplified manner, and in between, I will provide you some question relevant to the content. Again, similar to last week, since the lectures that were uploaded by NPTEL for this course for week 12, we have already discussed in the previous weeks, which were for retrofitting. So, following the initial module distribution that was presented in week 1, I will continue by discussing about steel structure today. And today in steel structure, we will have an overview of steel infrastructure. When then we will see what are different challenges that a steel infrastructure faces, how we can identify distresses, reasons in steel infrastructure, and then we'll talk about how we evaluate the performance of steel infrastructure. Once we have understand the challenges, distresses, and performance evaluation, we'll look into different repair and retrofitting techniques that are used for steel infrastructure. And finally, we will see some questions on the discussions that we had today. And once we went through the session, we will conclude the learning drawn from the interactive session. So, in the last live session, we continued our discussion on earthquake retrofitting. So, we said then that the need of seismic retrofitting of buildings can arise under two circumstances. First, for earthquake damaged building, where the building has already been damaged due to earthquake. So, in those buildings, we may need to offer some retrofitting measures. And second, is the earthquake vulnerable building where the building is not yet experienced any severe earthquake. So before earthquake, how we can retrofit or safeguard the building against seismic activity. In this, we first had an overview for the need of retrofitting. Okay. And then we discussed these points. We addressed problems faced by the engineers also, like lack of standards, doubt in effective retrofitting technique, and absence of consensus of appropriate method. And we highlighted various reasons which are responsible for arising the need of seismic retrofitting, like changes in design code, structural deficiencies, inadequate strength, functionality change, and lack of safety measures post earthquake. Based on these points, we divided retrofitting measures into three ways, either as increasing the strength, or increasing the ductility, or increasing both. For all the three cases, we had a relatively brief discussion, as can be seen in the figure also. So, if the existing building has an undesirable performance in terms of seismic capacity, in terms of required seismic capacity, by increasing the strength, we can increase the lateral strength of my system, which will be able to resist the seismic load. By increasing the ductility, I can increase the capacity of my building to undergo deformation before failure. And by increasing both strength and ductility, we can control both strength and stiffness and the seismic capacity of a building. And for all these three cases, we saw what is the response of shear force versus deflection. Then, for achieving these measures of strength and ductility, we classified seismic enhancement of seismic capacity of existing structure into two categories. First is the structure level approach of retrofitting or global retrofitting, where the complete structure undergoes seismic retrofitting. And second is the member level approach of retrofitting or local retrofitting, where a certain member is retrofitted against earthquake activity. For each of these category, we talked in brief about several techniques that are shown in the flowchart also. So for global retrofitting, we talked about shear wall, infin walls, bracing, buttresses, wall thickening, mass reduction, and supplementary damping and base isolation. While in local retrofitting, we talked about jacketing of beams, jacketing of columns, jacketing of beam column joints, and strengthening individual footings. Now, to link these methods to infrastructure, for each method type, we saw several special infrastructure example where those techniques have been opted. So, as you can see in this slide also, for global retrofitting, we saw several infrastructures. Like in the first structure, we talked about how Adding shear walls and infill walls was used to retrofit the structure. While in this Salesforce towers in San Francisco, we saw how bracing was done to increase the retrofitting. Here again, we saw how wall thickening and mass reduction was done in the bridge to increase the seismic to retrofit the structure against seismic activity. Here we saw how masonry structures were repaired by adding increasing the wall thickness. In the steel structure frame structure, we saw how moment frames were used. In this city and county building in Salt Lake, we saw how base isolation and in between floor seismic supplementary damping was used for retrofitting. And we also saw how base isolation can be carried out at mid-story level and at below ground level. Okay, so this was what we discussed for global retrofitting. In local retrofitting, we talked about jacketing for different components, like for columns, concrete jacketing, steel jacketing, strap jacketing, or using FRP. In case of beams, we talked about three-sided jacketing and four-sided jacketing. And for joints, we talked about longitudinal steel with the tie bars and just longitudinal steel jacketing. And again, for local retrofitting, also we saw several real field iconic examples where jacketing was used for seismic strengthening, like the case one where the Akashi Kaiko Bridge, one of the longest suspension bridge in the world, was retrofitted by using jacketing method, while this structure in Istanbul also was retrofitted using jacketing. And some major examples in India, like Mumbai Pune Express flyover and the CSMT uh, terminus of Mumbai, where this jacketing was used for seismic retrofitting. Finally, we talked about different measures that can be opted during the design of infrastructure only to minimize the risk of seismic damage. In this, we talked about reinforced structure, which will enhance the ductility, flexible foundation, which will be able to absorb more vibration, use of seismic isolations and damping systems, which will take vibrations away from the substructure, proper anchorage to increase the joint strength, redundancy in structure element to make it more stable against earthquake events, rigid joints so that the drift is minimal, lightweight materials so that we can reduce the weight of the building, which will reduce the shear force acting, which will reduce the lateral force acting on the higher stories, and compliance with building codes to ensure that all the structural elements are designed properly. Later, we solved some objective questions also to conclude the session from the learnings that we draw. So this was all for the week 11 content. Okay. Now, till date, our discussion has been related to concrete based infrastructure or masonry structures. However, there is one more category of infrastructure which is often used in mega constructions. These are steel structures. Okay. So steel in general plays a very important role in constructing vital infrastructure worldwide, from large scale and small bridges to tunnels, airports, train stations, and car parking lots. Okay, now why steel is so widely used? Here are some examples or some advantages of using steel as construction materials. It offers a very high strength to weight ratio, okay, which makes the use of steel suitable for mega construction project. Second reason is its durability due to its superior resistance to deformation, fatigue, and cracking, which makes steel suitable for use in construction. Third, and the most important, is versatility and flexibility. Owing to its superior ductility, steel offers a very good design flexibility for architectural forms, large span, and complex geometries, which increases or suits makes it more suitable for use in infrastructure. Speed of construction due to prefabrication and rapid erection techniques, steel enables faster construction scheduling and reduces the project timeline. And sustainability, since steel is a recyclable material, it lowers the environmental impact. So these are the major reasons which offers advantage of use of steel in infrastructure. Due to these reasons, steel as in whole, or we can say as a standalone material itself, is commonly used in infrastructure projects. Now, just to emphasize on the importance of steel, let's see some example of some major or some famous steel structures that are there around the globe to understand how versatile the application of steel can be in the infrastructure project. So, in the first image, you can see the Taipei 101 tower in Taiwan. So this tower is about 508 meters tall, and it is the 10th tallest building in the world, and it is purely constructed with steel. So you can see why, due to the high strength to weight ratio, versatility in the design, and the durability in the construction, how such long high rise buildings can be just only made by steel. Okay, in the second image you can see the Gherkin in the United Kingdom, where around 35-kilometer length of steel was used for the construction, having a total weight of around 10,000 ton. Okay, so due to high versatility and flexibility in design, you can see how a very aesthetically pleasing structure was being able to be created just only by steel, in addition to its high durability, superior durability performance. In the third image, you can see the Bird's Nest National Stadium in Beijing, that was created solely by steel. So, in this structure, this is the world's largest steel structure that is there currently, and it has a staggering 120,000 120,000 tons of steel used in its construction. So this structure was solely constructed with steel, and you can see how a complex geometry was possible due to versatility of steel. Then there is this unique steel house in Texas where 150 tons of blackened steel was used. Each piece of the steel was welded by hands and was created with virtually no outside assistance. So you can see how the flexibility in design is offering a creation of aesthetically pleasing structures using steel. Then there is this gateway arch in Missouri, where a 610 feet tall arch section was created using 900 tons of stainless steel, making it one of the most significant stainless steel projects in history. Due to its lightweight and its durability, you can see how such tall structures was able to be created with steel. Then there is Burj Khalifa in Dubai, which is a very known, very famous structure where around 39,000 metric tons of reinforced steel was used, while 15,500 square meters of embedded stainless steel was used for construction. Apart from these, if we take example in India, then we can see this Restello, India's first all steel residential building, where steel was used as the main construction element, and about 500 metric tons of steel was used in this construction. And this structure was constructed in the mid 2010 to 2020 uh, time, and it was completely by steel, offering a major example for use of steel as a construction material. Now, through this example, we can see how vast the application of steel can be in the construction. But despite having so many advantages, steel structure often face several challenges, which limits its application or which degrades its performance over time. Okay, so such distresses in steel can arise due to several factors. These factors includes design deficiency. The reason behind this can be use of undersized member, inadequate connection, or insufficient bracing. And this leads to structural instability, insufficient load carrying capacity, improper design distribution, improper load distribution. Second reason is material degradation, uh, which results from mainly corrosion and sometimes fatigue also, and it causes performance degradation over time. Another distress reason can be environmental exposure. which can be due to temperature variation, humidity, ultraviolet radiation, pollutants, and chemical exposures. And this can result in mechanical damage, erosion, and impact loading on steel, which can also cause distress in steel. Then there can be construction errors due to improper welding technique, inadequate bolt tightening, and incorrect installation of connection, which can lead to weak joints, stress concentration, and discontinuities in the steel infrastructure. And finally, there are operational conditions like increased traffic, heavy machinery, and changes in occupancy. Due to such conditions, there can be increased load, fatigue, and localized damage in the steel structure. So these are various challenges that are offered to a steel structure. Now, understanding the major reason behind distresses is important as a consultant and engineer. Okay, why? Because it will help us to implement effective retrofitting, repair, and maintenance technique. So, what we saw in the last slide was the background of how different challenges can appear. Now, what are the impact of these challenges? The impact is the distress, and how distresses appear in a steel structure. Let's see some examples or some reasons of for distresses. Okay, so first example is a corrosion. So corrosion, as we know, is the most significant cause of distress in any steel structure, particularly in environment with high relative humidity, moisture, and exposure to corrosive substances. And corrosion can occur due to atmospheric condition, chemical exposure, water infiltration, or inadequate protective measure, which can cause a large degradation in a steel structure. Second reason for distress in concrete can be fatigue, that occurs due to repetitive cyclic loading. It causes progressive damage and crack initiation in the steel components, and it can result due to fluctuating load, vibration, and insufficient detailing and connection, which can lead to distress. Third reason can be excessive loading beyond the design capacity. So suppose we have designed our steel structure for a certain capacity, but we are loading the structure above the capacity. So this what this will do, it will induce overstresses and deformation in the steel member, which can lead to distresses such as bending, buckling, and collapse. This can result from change in usage, improper load configuration, or unforeseen events like impact load, seismic forces, and vehicle collisions. Further, we have welding defects, which can occur due to lack of fusion, incomplete penetration, porosity, or cracks in the weld integrity, and this can result due to improper welding procedure, inadequate welder qualification, and lack of quality control during fabrication. There can be design flaws such as inadequate stiffness, bracing, member sizing, or detailing, which can lead to excessive deflection, stresses, and instability in the structure. Environmental factors like temperature variation, moisture, ultraviolet radiation, pollution, and aggressive chemical can also cause distresses in the structure in terms of surface corrosion, paint degradation, embrittlement, and material degradation. Poor maintenance can again be a reason for distress, where inadequate poor maintenance practices, neglected and deferred maintenance can lead to accumulation of damage, deterioration, and ultimately service structure failure. Okay, so these are like different reasons due to which distress can appear in the steel structure. Okay, so they in this slide we saw a major classification, and then in the next two slides we dig deep into some of the most important reason behind distress. Now let's dwell into a small exercise. So what we need to do here, we need to identify the reason behind the distresses as shown in the image. So you have four cases. Seeing the image, you need to identify what can be the reason behind the distress in all these four images. Okay, so I will wait for a couple of minutes for you guys to think and answer, and then I will tell you the answer. You can pause your video for a minute, think about the answer, and then play the video again. Okay, so let's see the solution for these cases. So in case one, you can see major deflection happened in the steel section with failure near the joints, and such thing can happen due to overloading of the steel structure. In the second case, you can see a cracking occurred near the joint or near the bolting section. This can occur if the design is not done properly, or due to fatigue also, if there is repetitive loading or cyclic loading, that can also lead to such cracking. In the third image, you can see clear spots of rusting everywhere on the steel, which is due to corrosion. While in the fourth image, you can see temperature heat related defect which can occur due to fire damage. Okay, so in this way, we can identify different distresses in the steel structure and the reason behind those distresses. Now, just knowing the distress and the reason behind distress is not sufficient. We also need to know the extent and the severity of distress for making proper repair and retrofitting choice. Okay, this can be done by evaluating the performance of steel structure. Okay, so as it is said, inspecting steel structure for distresses involves various methods and technique to assess the condition, integrity, and performance of a structural element. Okay, in performance evaluation, we can have several categories. The first and the simplest way to inspect is the visual inspection that we have often discussed during this course. So it involves visual examination of structural component, connection, welds, and surface coating for signs of distresses. And these signs of distresses includes corrosion, deformation, cracking, swelling, decoloration, and any other anomalies. Okay, as we saw in the last slide also, where just through visual inspection we reported what can be the reason behind the distress. The visual inspection can be conducted using different ways like handheld devices, binoculars, drones, for assessing difficult areas to reach. Okay, we can see in the images also, like we here we have some examples of visual inspection. Like in the first image, you can see inspection of joints. In the second image, you can see dimension check, and in while in the third image, you can see joint check again. That was done as a part of visual inspection. After visual inspection, we have non-destructive testing. So for steel inspection, different entities that are often used are ultrasonic testing, which utilizes high frequency sound waves to detect any internal flaws such as crack in the steel component. And this can also be used to measure thickness of steel member and assess corrosion loss. Second is magnetic particle testing. This applies magnetic field and magnetic particle to identify surface and near surface defects such as crack and discontinuities. Third is liquid penetration testing. This is very often, very commonly used in steel inspection, and it involves applying liquid penetrant to the surface of steel components to detect any surface breaking defects such as cracks and porosity. Another way can be radiographic testing, which uses X-ray and gamma rays to inspect internal structure of steel components for defects, voids, and discontinuities. If we try to see these entities through figure, so in the first figure, there's this magnetic particle testing. So try to understand what magnetic particle testing is. So this MPT involves detection of surface and near surface discontinuities in steel structure through the application of magnetic field. So what we do here magnetization of surface is done where the steel structure under inspection is magnetized using a magnetic field. This can be achieved either by direct magnetization, where a current is passed through the steel, or using permanent magnets or an electromagnet. Okay, so first thing is to magnetize the structure. Then, magnetic particles like iron or iron oxide particle are applied on the surface of the magnetized steel structure. Okay, these particles can either be dry powder or suspended in a liquid carrier. Now, these magnetic particles, what they do, you can see here, magnetic particle was sprayed, and using this U-shaped clip, the steel structure was magnetized. Okay, now these magnetic particles, they are attracted to areas where magnetic flux leakage is occurring due to surface or near surface discontinuities in the steel structure. So what will happen? These magnetic particle, they will accumulate near the discontinuities. Okay, and it will form a visible indicator or a cluster that can outline the shape or the extent of that discontinuity. Okay, so in this way, magnetic particle testing is used for inspection. Second is ultrasonic testing. So this involves use of high frequency sound wave, okay, to detect the internal flaw, discontinuities, and defect in the material. So first, a transducer, as you can see in this image, a transducer emits an ultrasonic wave. Ultrasonic wave has a frequency in the range of like zero point 0.5 to 15 megahertz. Okay, so this ultrasonic waves is transmitted into the steel structure. So what happens? These waves travel through the material, through the steel, until it encounters a boundary between a different material or a flaw within the metal. Okay, so suppose this is my steel element and I have emitted a ultrasonic wave. So there are two cases. If there is some crack or some void in the structure, then the my wave will be reflected back, or from the boundary my wave will be reflected back. So my base case will be by boundary reflection. So suppose this is my input signal that I have given. After a certain time, I will record a boundary reflection signal. Okay, if there is some void in the structure, what will happen? I will receive some reflection before the boundary reflection also, and this will become my judgment to detect the position and the intensity of the void inside the state. So what happens when we are emitting the ultrasonic wave? Some part of the wave is reflected back towards the transducer, while some part propagate through the material. Okay, so what we are doing, the reflected waves are again detected by the same transducer, okay, or a separate receiver, and the time taken for the wave to travel to the defect and reflect back is measured. And finally, by analyzing the characteristic of this signal, such as amplitude and time of flight, we can judge the presence, locations, size, and nature of defect in the steel structure. Third is liquid penetration testing. So as can be seen in the figure also, suppose I have a steel structure with a near surface defect, which is not visible to naked eye. So what I will do, first I will clean the surface thoroughly to remove any form of dust or impurities on the surface. Okay, once I have cleaned the surface, I will let the surface to dry. Okay, once my surface is cleaned and dried, I will spray the penetrant. So what will happen? If there is some defect inside the structure, my penetrant will enter the defect also, and it will stay at the surface also. Once I've applied the penetrant, after some time, I will remove the excess penetrant from the surface. So if there is no defect, my surface will appear like the original condition only. If there is some penetration inside the defect, it may not be visible to us right now because it is a very fine defect. Okay, now how to get the location of this defect? We will spray a developer. So what developer will do? It will suck out this penetrant from the defect out. So if we see some red coloration when the developer is applied, we can say that there was some surface irregularities or some defect in the surface where penetrant was getting stored, and its release will help us to decide the location of defect. Okay, and finally, we have radiographic testing. So this involves use of X-ray and gamma ray to penetrate the material. So what happens when X-ray passes through the steel? They are absorbed or scattered depending upon the density and the thickness of the material. So the area with defects such as crack, voids, and inclusion, they will attenuate this radiation differently, resulting in variation in the transmitted intensity. So if we place a detector on the opposite side of the steel to capture the transmitted radiation, we can see a radiographic image. Okay, in this radiographic image, the distress will appear as a dark or a light area on the image, because through the distress, there was loss in my signal strength or my input signal. Okay, this thereby will help a inspector to identify and evaluate the extent of distress in the steel structure. Another way to conduct NDT inspection is remote sensing and monitoring. So it involves use of drones, aerial imaginaries, lidars, and say satellite imaging, and it can be used to inspect large-scale steel structure or even from a distance. These technology provide high-resolution images and 3D models to visualize structures critically, as can be seen in the images below. Also, where drones are used to inspect the areas like some jetty structure in between oceans where it is difficult for an engineer to reach and inspect, or for structures bridge below bridge deck, the steel columns, if there are some steel columns there also, we can use drone to capture high visual images to inspect the structure. uh, in the adjacent figure also you can see one example where a sensor drone was used to inspect building. So what happens, there we have a source. Okay, source will emit some radiations. Okay, these radiations will be reflected back from the building, and they will get captured by the sensors will then send this radiation to a reception or a processing unit, where from the processing unit the data will be interpreted and analyzed to see how much distress is there in the building. So this is also a very complex way, but a method in which inspection of infrastructure can be carried out. Finally, there are destructive testing where we have tensile strength test, which can be used to judge the tensile capacity of a steel. So here you can see a steel beam, okay, undeformed steel beam, where you can see under tensile testing how necking was formed. We can do the bend test to check the ductility or stiffness of my beam. So the major aim of bend test is after 180-degree bend or 270-degree bend, there should not be any crack in the beam, okay, in the steel rebar. So that is a qualification test, qualification criteria for bend testing. Then we can have compression testing of steel. So suppose we are applying some wrapping on the steel, what is the effect on the compressive strength of the steel, that we can judge. We can have an impact test on steel where we will create a crack geometry in the steel beam, and using a striker we will try to impact the beam at this location and try to see what is the resistance that the steel is offering to the impact. All these testing can be done in a repetitive cyclic form also to judge the fatigue criteria of the building. As shown in this figure, you can see how as the number of failure cycle is increasing, how the strength of a material decreases and then it gets stabilized. So that is fatigue testing, that can also be carried out as a destructive testing. Now, after investigating the existing structure and knowing the severity and reason behind the damage, we can go for retrofitting and repair of civil infrastructure. So, investigating the existing structure will give us the reason and severity of damage, and this will help us to adopt suitable remedial measures. Now, this retrofitting objective may vary depending upon the requirement and the goal of project. Okay, so common objectives of retrofitting can be enhancing the structural strength or stiffness, which is needed to accommodate increased load or changes in occupancy. Then one more reason for retrofitting can be to improve the structural resistance against seismic load, wind load, or blast load. That is nothing but increasing in lateral load carrying capacity. Third reason for retrofitting can be correcting deficiencies near the joints that is identified during structural assessment. Okay, which can occur if the building codes and standards are not followed properly, or if there is some update in the code. Fourth reason can be extending the service life of the structure to address durability concerns like corrosion, fatigue, and deterioration issues. And fifth point can be upgrading the building system, such as electrical, HVAC, or fire protection to meet the modern requirement. Okay, among these objectives, we will try to talk about each of objective one by one, and how different retrofitting measures can be opted for a particular objective. So the first one is strengthening of steel of the structural element. Okay, this is done to increase the load carrying capacity and resistance to bending, shear, or torsion. Okay, and this can be done either by using steel plate, carbon fiber reinforced polymer, or steel angles. Okay, so as we have seen in the concrete retrofitting part also, the same discussion is here. So you can see in the images some of these examples. So in the first image you can see a steel I beam, where CFRP was attached at the base of the beam. So suppose some load is acting at the top of the beam. So what it will do, this is the tensile part, and CFRP addition, it will provide the additional tensile capacity to the steel beam, which will help to increase the strength of it, which will strengthen the steel beam. In the second image, you can see three-sided wrapping was done using steel plates on the steel beam. So these wrapping, what they will do, they will increase the shear strength also from the side, and they will increase the flexural strength also from the bottom of this steel plate. In the third image, you can see additional bracings are provided to support the steel buildings. So sometimes when the steel has completely lost its activity or it is in the very near stage of getting collapsed, such retrofitting measures can be opted. Then for seismic strengthening, that is the way out is to increase the lateral load carrying capacity, and this can be done by using supplementary basings or moment frames apart from base isolations. Okay, so as can be seen in the images also, there are several ways to offer seismic isolation or seismic strengthening to the structure. So in the first image, you can see moment frames that were used. So you can see cross frames, they were used. So what these cross frames would do, so if you see in this example of braced frame and unbraced frame, so in unbraced frame, due to seismic activity, when some lateral loads acts on the frame, there is a large drift in the structure that can occur. However, due to bracing, what will happen? The stiffness of this joint will increase, and since the stiffness of the joint will increase, the deflection will decrease, and your structure will undergo very less deflection. It will be able to resist the seismic load. Okay. And the second image, you can see again side bracing was done to increase the seismic load carrying capacity. While in the third image, you can see moment frames were used, supplementary bracing systems were used to increase the lateral load carrying capacity of the building. Another way to strengthen the steel infrastructure is to go for joint strengthening. That joints are often very critical part of a steel structure. That's why in design code for steel, we are also designed for joints very critically. Okay, now for joint strengthening, it can be achieved by upgrading the connections with high strength bolting, welting, or adhesive anchors to improve the load transfer or ductility. So you can see in the first two images where high strength bolting was done near the joints to increase the ductility and load carrying capacity. While in the third image, you can see how anchor bolts were used to improve the load transfer capacity from a steel member to the ground. Okay. While the other case can be corrosion protection measures, as we know, steel is prone to corrosion, especially in environment which are very severe for corrosion. So in such cases, we can use coating systems, cathodic protection, and sacrificial anode to mitigate corrosion and extend the service life. So as you can see in this images also, in the first image, you can see there's the steel columns that are embedded in that are present inside the water. So generally what happens, seawater contains a lot of chloride ions, and chloride ions are very severe for corrosion. So what will happen if there is no protection measure used? So what will happen, initially your columns is looking like this from side view. Due to corrosion, your column will lose its area, cross section area, and due to this area will become critical for stress failure, which can lead to collapse of my structure also. So to mitigate this from happening, what we can use a sacrificial anode. So here in this image, you can see zinc was used as a sacrificial anode, and it was attached to the steel. So what this will do, zinc will become as anode, and my steel will become the cathode, and corrosion happens on anode. So my zinc will corrode while my steel will be protected. Similar way, you can see in this second image where a aircraft plane was attached with different sacrificial anode system on its surface to mitigate the corrosion issue, while the surface of the aircraft was also painted with a protective coating to limit the corrosion damage. In the third image, you can see underground pipeline made of steel. So again, groundwater also have a very high concentration of aggressive ions which can cause corrosion. So to mitigate corrosion in such cases, what we do, we use district anode system. So these are district anodes. Okay, these anodes have more capability to corrode as compared to iron. So what we do, we connect both of these systems. So due to this, my iron becomes cathode, and these anodes become these discrete metals become anode, and they corrode, protecting the steel. Okay, so in this way, we can see how corrosion protection measures can be used for retrofitting and repair of a steel infrastructure. And finally, there is this fire protection. Okay, so it involves use of enhanced fire resistance measures for steel infrastructure to maintain the structural integrity even during the fire events. So techniques for fire protection measures include applying intumescent coatings, applying fire resistance enclosure, and adding fireproofing materials. Okay, so as can be seen in the image, we have an unprotected steel where at a critical temperature of 500 degrees Celsius, steel started to lose its strength, and fire resistance may be far less than 30 minutes. So within 30 minutes, you may see this whole beam will collapse. Okay. However, if we apply some fire resistance coating on the steel surface, what will happen under fire also, this coating will be able to protect the steel from fire scenario, and it will help my steel to function for a longer time. So in this way also we can retrofit a steel structure. So this was all about retrofitting of steel structure. So we saw several examples. We first saw several objectives on which the retrofitting method depends. Now for most of these things, we have seen retrofitting for rebars, reinforced concrete. So similar techniques can be opted here also, but still we have highlighted few of them. So first we discussed about strengthening, then we talked about seismic strengthening, we talked about joint strengthening, we talked about corrosion prevention or protection measures, and we talked about fire protection measures. Okay, I hope everyone are clear with this concept. Any doubts in this? Okay. In the meantime, if you have any doubts in the discussion that we had till now, you can write in the chat box. While others who don't have any doubts, they can go through this questionnaire. Okay. So just try to go through the questionnaires. I will pause the video I will mute myself for a minute and try to answer the questions on your own, else I will tell you the answer. And others try to type whatever doubt you had in the discussion till now or in general with the discussion of week 12. Okay, so let's see the solutions now. So the first question says, what is the primary objective of retrofitting steel structure? To increase the initial cost, construction cost? No. To maintain or enhance the structural integrity and performance? Yes, this is the correct answer. To decrease the lifespan of the structure? No. To introduce new design flaw? No. So these 3 points were showing negative impact, but retrofitting has a positive impact, so correct answer is B. Which of the following technique is commonly used for strengthening the steel members and retrofitting? Adding weight to the structure? No. If we are adding weight, we are making it more vulnerable to damage. Reducing the thickness of structure steel element? Yes, this can be one way. Strengthening with additional plates or section? Yes, this can be also one way. Applying water resistance coating? This can also be one way. However, the most commonly used one is the strengthening with additional steel plates and section. Why? Because reducing the thickness of steel elements can often be very difficult to execute on site. Okay, it can be difficult to make a proper steel surface even after reducing the thickness, and it can come in the form of aesthetic appearance also, or it may generate other forms of distresses in the structure also. So it can be used, but it is not very commonly used. And the last point, adding water resistance coating, it is used but for only some specific cases. Most commonly used technique is adding steel plates and section to strengthen the structure for both strength and ductility performance, for both strength and stiffness. Third, what is the primary reason for the use of chemical corrosion inhibitors in steel structure retrofitting? To increase the weight of the structure? No. To increase the thermal conductivity of steel? No. To prevent or delay corrosion in steel components? Yes, this is the correct answer. To enhance the aesthetic appearance? No. So how this corrosion inhibitor works? What happens when we use a corrosion inhibitor as an admixture in steel? What happens? These inhibitor, they move towards the steel and they form a film over the steel surface. Now, in the first session, we talked that steel is a corrosion is a combination of two reactions: anodic reaction where the steel degrades, and cathodic reaction where oxygen from environment comes to the steel surface and collects electron and form hydroxide ions, and the iron oxide, iron plus 2 state, combine with these hydroxide ion to form rust. Now if either of these reaction is occurring at a slower rate, the whole corrosion rate reduces. So what inhibitors does, they form a protective film over the steel surface. Now this steel surface, this film, what it does, it breaks the interaction of the steel with the surrounding, and in this way it reduces the rate of corrosion and it enhances the service life of the structure. Okay, I hope everyone are clear with these three questions. Let's see three more questions. Again, if you have any doubts, post it in the chat box and others try to solve these three questions. Okay, so let's see the answers. Which factor is a common vulnerability making steel structure prone to seismic damage? So the answer will be low strength of steel material, no. Insufficient design redundancy, lack of environmental exposure, over engineering of structure. So answer can be A or B. But if we talk about common vulnerability, then B is the more suitable option. Okay. Often in insufficient design redundancy, they lead to inadequate strength and ductility of steel, which offers reasons for various forms of distresses in the structure. What is the purpose of anchors installation in the repair of retrofitting? So we know anchors are installed for strengthening the joints. So these will help to provide additional support and stability to the structure. Okay, so this will be my answer. All other three are the negative impact, but anchors have positive impact on the repair work. Which type of reinforcement is commonly used to enhance the steel resistance to the structure? Adding more windows? No. Retrofitting with CFRP? This can be one reason. Removing steel beams and using steel bracing. So this can be one reason. However, when I'm talking about seismic resistance, my answer will be using steel bracing, because what will happen? You use of steel bracing, it will enhance the stiffness of my building and it will decrease the lateral drift in the building, like how we saw in the earlier discussion in today itself, where due to the addition of bracing, the deflection was getting controlled. CFRP can be used, but it is more related to the strengthening part, not related to enhancing the seismic retrofitting. So for seismic retrofitting, commonly used technique is steel bracing. Okay, so this was all for today's session. So in today's session, let's conclude the session. So the session introduced us to steel infrastructure, where we first had an overview of steel infrastructure. We saw some major examples of its application. Then we talked about various challenges that a steel structure encounters, which degrades its performance. We then discussed how performance of steel structure can be evaluated using visual inspection, non-destructive testing, and destructive testing. And finally, we discussed several measures that can be taken to retrofit and repair steel structure, starting from strengthening, seismic retrofitting, corrosion protection, and fire damage protection. Okay, so this was all for today's session, and this was all for this course, design and retrofitting and repair of civil infrastructure. If you have any doubts, I will be there in the meeting right now. You can ask your queries, else I will end the session. Thank you.